This is The Future Of, where experts share their vision of the future and how their work is helping shape it for the better.
Hello, I'm David Karsten. It's existed for thousands of years and been the topic of research, fascination and speculation for decades. Yet Stonehenge is a monument shrouded in mystery. While its iconic outer sarsen circle is known to many, the inner cluster of blue stones is sparking new interest, with questions swirling around the origin of the altar stone, a grey-green sandstone far larger and different in composition to the other blue stones. Today, I was joined by Curtin University PhD student Anthony Clarke and Professor Chris Kirkland, two experts who are behind a groundbreaking discovery about the origins of Stonehenge's altar stone. We delved into their research, the impacts of this information on our understanding of prehistoric Britain, and speculated on the ever-present question, how did this awe-inspiring monument possibly come to be? If you'd like to find out more about Stonehenge and Curtin's research on the topic, you can visit the links provided in the show notes. Stonehenge sits within the imagination of everybody to some degree, but let's drill down on what Stonehenge actually is. What does it mean and why does it continue to fascinate us? Tony?
I think Stonehenge is this enduring mystery. If we look at other ancient monuments, we know why they were built. We roughly know why the pyramids were built. They were a tomb. And we know why other great sites across the world were built. But Stonehenge, we have no idea what it was used for, why it was built, and importantly, who built it.
The mystery continues, and your work hopefully will go some way to solving it. Tell us about this latest discovery that both yourself and Professor Chris Kirkland have been instrumental in unveiling to the rest of the world.
So if we look at Stonehenge, all of the rocks seem to be this grey, upright stones in the middle of a green field, but they're actually quite different rocks. Some of them, the big upright sarsen stones, are from the local area. They're about 25 kilometres away from the site. The blue stones inside the circle, they're from southwest Wales, about 250 kilometres away from England. But the central 6-ton rock at the heart of Stonehenge, which is called the altar stone, was unknown. We didn't know where it was from. It was kind of the last puzzle piece in the Stonehenge story.
There were theories though, weren't there, Tony?
There were lots of theories. It was long thought to have come from Wales, along with the other blue stones, either over land or up the Bristol Channel through a shipping route. But recent work was really starting to move away from any kind of Welsh provenance, a Welsh source for the altar stone. So as of last year, or a couple of years ago, where it came from was unknown.
Okay, so this was something that you specifically wanted to solve, or is this something that between yourself and Professor Chris Kirkland here, you got together and said, look, with the tools that we're armed with here in Western Australia, we can actually discover what the origins are of these particular stones?
That's exactly right. Part of what we do here at Curtin is work out where rocks have came from, how they've travelled, kind of their history. And we use these tools that we apply every day to Western Australian questions and problems to this boulder, this rock at the centre of a monument in England. So it really was the same question, but a very different answer.
Chris, let's bring you into the conversation. Again, an accent that's not local to Western Australia. Why are there so many geologists in WA that originate from around the world?
Yeah, that's a lovely question. I think, WA naturally brings a lot of geologists, mainly because of the exploration industry. So the exploration industry relies on geologists because geologists read rocks and tell the story of rocks and use that information to predict where ore deposits are going to be. So really a geologist's job is to reduce exploration risk, and that's important. In fact, it's critically important for the WA economy and, society. Really understanding where our resources are is really important. But how we do that is we use these fantastic mass spectrometry tools that Tony's been telling you about to understand the age of rocks. And the age of rock is really important because it allows us to piece rock into its kind of story, its context. We know if rock is at page 1, we know if another rock is at page 10. If we know ore occurs roughly on page 3, going and then analysing the age of rocks helps us read the story within rocks and reduce the risk of going to find other ore deposits. But using the same tools, we can work out the provenance. That's the technical term for where material has come from. And that's exactly what we did at Stonehenge, this iconic site in the UK.
Before we drill down into, no pun intended, the mechanics of how this discovery came about, I'd like to know the Chris and Tony origin story, because I think that's a really important part of the overall narrative here. Now, Tony, where do you come from, and how did you get to Western Australia? What brought you here to work with Chris?
Yeah, well, I have to say there were lots of things pulling me to Australia and then lots of things pushing me from the UK, the weather namely. But my story starts in southwest Wales, actually near where some of the bluestones of Stonehenge came from. So I grew up wandering the hills and seeing these ancient quarrying sites, and that definitely inspired me to pursue geology and study it at the University of St Andrews in Scotland, where Chris studied some years before me. That then led me to the other end of the UK in Cornwall to finish off my education before applying and coming down under during the midst of the COVID pandemic, where I had to do quarantine. And I can say now it was completely worth spending 4 weeks in a hotel to do my PhD here.
Look, to paint a picture for our listeners, Tony, you're a young man. You're only in your mid-20s. So you've actually packed a lot into your career and into a very short space of time. And you've come to Western Australia to further your research. And in doing so, you've met Chris. How does this work?
Yeah, it was quite the kind of collaboration, but it was just as simple as applying for the PhD that was advertised, and Chris and Curtin has really facilitated my freedom to explore fascinating topics using the tools that we have here at Curtin.
So as the PhD supervisor in play here, Chris, Tony's come to you with this mad idea of a fascination that he's held close to his heart since childhood, and he's entertaining the notion of writing up a thesis on this. What did you think when he came to you with this?
Absolutely fantastic. Tony's PhD was basically about deploying these tools we've got to date rocks, understand geology, to different questions. So this is just a nice question where we can use geological tools to address an archaeological question. Some of Tony's other work was looking at the age of fossils, for example, using exactly the same tools, but again, a question that's normally done a very different way. So yeah, I think it's fantastic just using the toolkit that we have to address a wide range of different questions about Earth and our planet. And that's really what excited me about geology and earth science as a subject, and what got me into becoming a geologist.
You really captured your imagination with this particular project. And so what happened there? Did you both pack your bags and, both with clothes and this spectrometer and an associated toolkit and go all the way there? Or did you manage to get a sample and bring it back here? How does it work?
Yeah, I wish we could go to Stonehenge with a hammer and chip off a few samples. Unfortunately, we can't really do that. It's kind of frowned upon. But we were lucky enough to get a few samples sent down under. Very small samples. So you're thinking tiny fragment slithers of rock on a glass microscope slide. And the scale that we're working at really is so minute. We're working at the microscopic scale here. So these aren't chunks of rock that we're working with.
Okay, so the samples arrive and you work with those samples, and much to your astonishment, or was it just a cool, calm and collected sort of response, you discover that the rocks come from, not from Wales, but from Scotland.
Scotland, yeah.
Yeah. Okay.
So there's a whole piece of science just to get to that I think is quite cool. So you basically have, a thin section, which is a little thin sliver of rock, right? And we're going to fire a laser beam at individual crystals within that rock to work out their age. And the clocks within these crystals are very cool. So they simply revolve around a bit of uranium, and uranium changes to lead over time. So if we can measure the amount of uranium and the amount of lead, and we know the rate these things change at, that's an inbuilt clock. So Tony firing his laser beam at lots of these little crystals built up this fingerprint of all the ages of the different crystals in the sandstone, the rock, the altar stone. And that we can use like a DNA fingerprint to match to other rocks within Britain and Ireland, even around Europe. And that's what gets us to allow to say with some degree of certainty, actually greater than 95% certainty, that the altar stone didn't actually come from Wales at all. It came from the Acadian Basin, so northeast Scotland.
What are the implications of that discovery? Does that change our understanding of?
You bet it does.
How those folks actually, carted really large scale rocks around the country?
6 ton rocks. Yeah, 6 tons rocks. So I make this joke, and I think Tony likes it as well. Like, even today, carting a 6-ton rock from northeast Scotland down to southern England would be a massive task. I'm not even sure you could. You might get a lorry and you'd try and do it, but it would be a very difficult task. So spare thought for these guys in the Neolithic shifting this size of rock. And that brings us then to think about the society and the connections within that society and the technology they had to allow them to transport this amount of rock.
Tony, with the examination of those samples and the discovery that they weren't from Wales, are you able to then locate with a degree of accuracy whereabouts in Scotland these rocks would have been quarried from? I mean, were they close to the coast, and did that enable sea transportation, or were they inland, and would it require an overland type of transportation?
So the Orcadian Basin that Chris mentioned is quite a large area in northeast Scotland. It's several thousands of square kilometres, so it's a big area, but we've managed to narrow it down to this area. This basin crops out. It occurs on the Orkney Islands, on the mainland, and even as far north as Shetland. So we can't say right now where it's from in this basin, but if it came from Orkney, then it would have had to involve some degree of shipping. If it came from the mainland, then maybe overland shipping is looking more likely. The hunt's on now to find exactly where it's from.
Are you willing to offer up a theory?
If we look at northeast Scotland, it is an area packed with Neolithic sites. Orkney is world famous for Skara Brae, the Mice Tomb. These are world famous Neolithic sites. So clearly it was a population centre. 4,000 years ago, it was a centre of trade and farming and culture. So if I had to put a bet on it, I would maybe look at those islands off the coast of Scotland.
Sea transportation, in other words. That's phenomenal. That's a phenomenal thing to consider, isn't it? Transporting in a vessel a 6-ton slab of rock.
If we look at the area, if we look at the archaeological evidence, there is evidence of a shipping network at that time. We find jewellery and masonry and pottery and animal bones that have come from definitely the mainland and even as far as continental Europe. So these people were seafarers.
Yeah, you think about it another way. Just think about all the mountains and valleys and all the topography that they would have had to shove a 6-ton rock over. It seems very challenging to think about an overland transport. That's possible, but just in terms of the efficiency of the energy being expended, it seems much easier to devise a mechanism to get it onto some sort of boat. And like Tony says, we do know they had communication networks that required shipping of some degree. It's just the fact that this is a 6-ton block. And then you think about all the other things that means. That tells us something about their technology. Their shipbuilding technology, for example, if that's correct, was more advanced than many people might have thought.
For those of us not that familiar with our British geography, once the vessel had sailed down the coast, how much overland travel would have been required to get those rocks from or that rock from coast to where Stonehenge is located?
Yeah, so I think that's actually an interesting question, because if we look at where Stonehenge sits, it's actually relatively close to 3 major rivers. So potentially there's some interest there about maybe were they able to use rivers as well. But, undoubtedly there has to have been some element of overland transport. It's just not maybe the 650 kilometres from the north of Scotland. But as geologists, we're able to say things with certain degrees of certainty because we use mass spectrometers. So we're very comfortable with those ideas because we can place confidence bounds around them. When we start talking about the archaeological parts of the story about transporting this material, that's more challenging because, that's where the evidence is lost, and all we're left with is piecing together the pieces of evidence as best we can to come up with the best hypothesis.
But that's the fun part, Chris.
Yeah, it is the fun part.
That's the fun part.
Yeah.
So Tony makes these discoveries, and what does he do? Does he draft up the paper, or does he give you a call first and say, well, look, Chris, this is what I've found, and what was your reaction?
I remember going into Chris's office, showing him my screen, sharing my screen with him, and we went, hey, these ages that we're getting from these grains are ancient, truly ancient, well over half the age of the Earth. And then we looked at a geological map of the UK and said, where do you get old rocks? Well, the answer was north in Scotland. And it was just this incremental, more data, increasingly Scottish was our kind of conclusion.
Yeah. Yeah, so it's not just one data set. We dated lots of different mineral grains, and each of those mineral grains tells their own story, but essentially all the different mineral grains that were dated were distinctly Scottish. And the nice thing, if you like, about the British Isles is it's got a real variety of different geology. So in southern England, there is younger rocks. In northern England and in Scotland, mainly Scotland, you get much older rocks related to North America. So there's a big suture zone, a big zone where an old ocean used to be. So that's kind of useful for us trying to provenance material because these distinct regions have their own unique fingerprint. So their DNA, if you like, in the rock is different. So that makes it easier, if you like, to provenance where the material has come from. So yeah, it was a case of week on week building up more and more evidence. And then we got to the point where it was like, yeah, we think we can write something.
Well, you write something, you publish, and then it's released. And the world takes notice. What was, firstly, the response within your field?
I think the response from geologists and geochronologists has been, this is a really cool application of these techniques to answer a popular science question, but also an interesting archaeological mystery that's endured.
Yeah, I think that's a good answer and reflects definitely from the geological community, they recognize the use of the geochronology tools, the isotope tools, and they're really, I think, supportive of that. The archaeological community, I think, that's where there is other maybe ideas about where material has probably come from, and there is other ideas about glacial transport, so material being shifted by a glacier southwards. For certain reasons, we don't think that probably works.
I would suggest it would take a long time for if these guys were working to a deadline. Glacial transport would suggest that it probably wouldn't happen within one lifetime.
Yeah, well, I think what they're suggesting is maybe a glacier moved this rock further south, and then someone picked it up just because it was a nice rock close by. But the fact is, if you look at glacial transport lines, they're in the wrong direction. So there's actually taking stuff further away. So that for us doesn't work. There's also evidence about, very carefully selected rocks. So why would you pick a random rock to put in the center? I think our data points to a different transportation mechanism than some people maybe thought. And obviously in science, when you present a new data set that has wide-reaching ramifications, it takes a while for the community to fully digest and understand what that means. And that's kind of normal in science and how science progresses.
All that said, the wider community, i.e. the rest of us, we've kind of embraced this. The response to this was so positive.
Yeah, definitely. But I mean, the thing is, obviously in the UK as well, they feel a strong connection to, it's their biggest kind of historic landmark. So I think being able to say something about that as a geologist is really a kind of if you like, a moment to put down and recognize in your diary as, this was something really cool we did. The science behind this story as well, I think is very robust, and that's an important part of the whole concept as well, that we're able to robustly say these scientific facts, but they have meaning for society as well, because it's such a cool site. It's really iconic for geologists to be able to go and work there.
There just seems to be an enormous sense of satisfaction on a couple of fronts for both of you with these results. In terms of the science into the makeup of this rock and where it's come from, does it contribute anything new to the speculation as to the purpose of Stonehenge, Tony?
Yeah, well, the altar stone at the centre of Stonehenge was clearly an important feature of the monument. If we look at the astronomical alignment that we know Stonehenge has, the altar stone is a focal point of these astronomical alignments. The sun casts its final rays of light on it in the winter solstice, and in the summer, the rising sun casts its first rays on it. So it's important. Its purpose in Stonehenge, we don't know what it was used for. Was it a calendar? Was it a kind of a tool to keep track of farming in the seasons? Yeah, these are the great unknown and maybe unanswerable questions.
But I think, some people say, Stonehenge has been used for multiple different things over its lifetime. The stones have been partially rearranged in places. Some stones have come from elsewhere. So it's like, a temple at one part, maybe a feasting area in another part, a calendar in another part. So it's like this fantastic building that's gone on for a long time, that's had different uses. But, I find it profound to think that in the Neolithic, people had a society so advanced they were able to transport material this far. If you think about what that means, it kind of suggests that, societies we always seem to think are ever progressing in one direction. It's potentially not like that at all, and that's quite profound. Societies may develop, but then regress only to develop again. So it's not just a continuous upward evolutionary march. There can be dips and rises and dips and rises, and I think that is quite profound to think about.
It's very easy to conclude that, like you say, development is always going forward, and that we perhaps underestimate past civilizations, isn't it? It's very easy to underestimate.
Yeah, absolutely. I think that's one of the nice things in the wider context of this story, that it kind of points out that while technology generally is progressing, there may be periods when certain aspects of technology have regressed. So, back in the day, to use a parochial term, maybe they had a fantastic mechanism of transporting blocks of stone that we don't know about today. In fact, there's been some tests with large blocks of rocks that suggest you can transport them with sliding them on seaweed.
That's amazing. That's your next one. That's your next one, Tony.
That sounds good. I'll go down to the beach, grab some seaweed and bring it in.
Look, we've speculated about the different purposes of Stonehenge, different parts of it through time, but we haven't covered the possible extraterrestrial, contexts that are attached to Stonehenge. Do either of you have any thoughts on that? Well, firstly, what are the theories?
So I think, there's several theories about how it was built. Some think it was Irish giants that maybe constructed the site. Others think it was, aliens, an alien landing ground of some kind.
Mm-hmm.
Or what are some of the other theories that you heard when we were in the UK?
Irish giants, right from that walked across the causeway.
They were recruited by Merlin, the wizard Merlin, I think.
Merlin, I think, had something to do with it as well, and probably King Arthur, and there might have been a sword in a stone, or am I getting confused?
Yeah, I think that's it. But again, it goes back to we don't know why or how it was built, so it attracts these theories.
Getting back to some of the science, there is extra cool stuff that we can say, because the recent history of the stone, and by recent history of the stone, I mean, it's Neolithic history and its transportation. So that for us as a geologist is just scratching the surface. As geologists, we kind of are more used to talking about what I call, and geologists generally call the deep time history. So that's history that kind of boggles the mind, and it's really where geology is kind of one of these special sciences, because what we can tell from the rocks and the analysis that we did of the altar stone, we can tell the history of that crystal. It ended up getting eroded out of granites. So these are, like your kitchen bench top. Those granites themselves are about 400 million years old.
Jeez.
Yeah, exactly. 400 million years old. There was a mountain range in Scotland that ran all the way into North America. That mountain range eroded, and those little crystals got transported into a basin. That basin, that sedimentary basin, like a beach, had fish swimming around in it, some of the first fish on the planet. That basin and the stones that were in that naturally break. They form really nice flagging stone that forms, many facing stones on buildings. But in the Neolithic, people thought so much of that stone, they wanted to use it as well. So that's what I mean about the deep time history. And we can go back even further. I think, Tony, some of the older grains are even older than that 400 million. Isn't that right?
Yeah, we're talking 3,000 million years old, so well over half the age of the Earth. And that's all recorded in this sandstone at the center of Stonehenge. So we think of it as this 4,000-year-old monument, but to me it has this way cooler and way deeper history going back into deep time, like Chris said. I think it's a fascinating aspect.
I'm having trouble just trying to comprehend that number. That is a very old rock. That's phenomenal.
So yeah, the components that went into the rock are very, very old. The rock itself is old, but not that old. Like compared to Western Australia, where we do most of our work, most of Western Australia is much, much older. But the individual little grains that make up a rock, they're what has these really old signatures. So what we do with our students, which is quite fun, we get them to stretch out their arms from arm to arm, and that's the length of time from, on the left-hand side, that's when our planet formed 4.5 billion years ago. On this side, my other arm, that's today. If I shave my nail, that's all of human history gone. And what we're talking about is probably somewhere around my elbow. We're talking about material that age. with other components that are much older as well. So that's how we try to rationalize. It's really hard to talk about such magnitudes, right? They just boggle the mind.
Well, that certainly helped the arms. I'm a visual man. Thank you for that, Chris. Has this discovery gone some way, as small as it might be, to solving how Stonehenge actually came to be?
I think, if anything, it's added to this mystery now. We know that Stonehenge is this kind of monument made up of carefully selected rocks from each corner of the UK, England, Wales, and now Scotland. So what on earth Neolithic people were doing some 4,000 years ago to curate and collect all of these rocks and take them to England, we'll never know. I think it's just added to the mystery.
Chris, what has being part of this journey meant for you professionally?
Yeah, I mean, it's like I said, it's an iconic location in the UK, which is home to an awful lot of, historical geological thought. So it's a really nice, fulfilling moment because we can deploy all the scientific techniques we've developed here at Curtin to date rocks to a really neat question. And that's really cool to see a different application to, science I've been working on for over 25 years now. So that's really nice to see a different use of science that we carry out on a day-to-day basis. We have mining companies coming to ask us to date ore deposits. Yeah, no problem, we can do that. Okay, let's look at a piece of pottery now. Let's look at the provenance of where a piece of pottery comes from. We can do that now. Let's look at other archaeological artifacts. That's kind of fun.
Yeah, the altar stone was just the beginning, really. I think there's a world of ancient artifacts made of rock that we can work out where they're from. And so we can work out how Neolithic people were communicating and the cultural links they may have had both in Europe, in the UK, but I think of Australia, and I think of kind of the potential, the untapped potential of the tools that we have here.
So we're saying that this research project and the tools that you've used in it have the potential really to change the way archaeology is conducted, or elements of archaeology.
I think so. I think it helps us understand that kind of societal connection, and it's done in a way that's very, mathematical, which in some ways is nice because we can place confidence bounds on the answers. So it means we can give really quite good degrees of certainty to where material has come from, and that really allows us to map out where society was able to transport things and the communication networks. And that's important because it allows us to understand, how connected a society was, which tells us about their technology, but also might lend to ideas about how peoples have moved across the planet. Australia for one, but the UK in the Neolithic. So there's a huge wide range of extra science questions I think we can address.
That's really exciting, isn't it? I mean, come on.
Yeah, it's pretty cool.
Yeah, it's really cool, and I have heaps of ideas on how we can implement these tools going forward. Like I said, in Australia, to look at the pre-colonial history that we have here, and in Europe, I think it's just the start really of what we have.
As geologists, you're both very much at home here in Western Australia, but Tony, in terms of this project of making this discovery related to Stonehenge, what does that mean to you as a Welshman that spent a fair bit of time around this type of rock, but also visiting Stonehenge? I mean, there's photos of you, isn't there, of as a really, really young tacker?
Yep. Yeah, it's always meant something to me, and I think growing up where I did and seeing the rock on the hills that eventually was delivered to Stonehenge, it's been inspiring, and to contribute something to this story that's been 4,000 years in the making is it's been a huge kind of privilege, really, and it's been an exciting piece of work, and it's been this great collaboration between Curtin and Adelaide University and colleagues in the UK. So it's been great training as part of my PhD.
What's next for the both of you, and does it involve these techniques and the tools that you've used thus far?
Well, yesterday was my first day on the job as a employee of Curtin University and no longer a student.
Welcome.
I'm just getting my getting started really, but there's so much to learn about ancient history and geological history using these tools, and I can't wait to get started.
And Chris?
Yeah, so Tony's joined the timescales group. So yeah, we're going to deploy the SIMS tools to address a wide range of other scientific questions. Some will be decidedly geological for the exploration industry, but some will be maybe more directed to other scientific fields, and we've got a few ideas about other exciting samples that we think we can provenance, tell people where material has come from. That's some fun stuff that we're looking forward to coming back and talking to you about.
Well, Chris, just for those of us that are perhaps unfamiliar with the Timescales Group, can you just give us a brief understanding of its remit, how long it's been in operation, and what it's been up to?
Yeah, sure. So the Timescales Group is basically a research group in Earth and planetary science, and we use the fantastic mass spectrometry, those tools that allow us to date rocks that we have here at Curtin to produce interpretive products, mainly for the exploration industry, but also geological surveys. So, frequently we'll be called up and asked to date rocks to help make a geological map. And that's very satisfying because you can see these maps coming together by placing numbers on them. Like I keep coming back to this, the tools that we deploy are really applicable for doing other sorts of provenance tracing. For example, we've just done some work looking at other mineral grains, and those mineral grains maybe could be linked to better soils for winery regions. So the same sort of tools being used for a wide range of different purposes.
Very noble industry, that one.
The samples are very fun.
Well, gentlemen, it's just so exciting to talk to both of you, have you both come in and talk to us about this discovery. We've certainly all enjoyed the media in the lead up to this and watching, I guess, the findings take flight in the wider world. So both of you, Chris and Tony, thank you very much for coming in today.
It's been a pleasure. Thanks for chatting.
You've been listening to The Future Of, a podcast powered by Curtin University. As always, if you've enjoyed this episode, please share it. And don't forget to subscribe to The Future Of on your favourite podcast app. Bye for now.